At the end of this program, we should.
Can we record this so that?
Yes, I'm recording.
Yes.
I'm recording.
Oh, okay.
At the end of this program, we should be able to achieve the following. BGP. We should be able to pair with eBGP and iBGP. We should also be able to build a transit autonomous system using BGP. And we have some knowledge on route reflectors. I think this one is light, BGP light, but as I was preparing, I realized that BGP, there's nothing light about it. I realized that if I limit myself to the BGP light, you're not going to have a real feel of the BGP. So we'll add some stuff to what we have here, okay, because this is too light. Learning about the transit autonomous system and route reflectors alone will not be fine for us. Then our main focus, MPLS. We should be able to build an ISP network. So by the end of this course, if you have any contract to build an internet service providers network, you should be able to do that. Okay, even though normally it's a challenge moving from the lab environment to real life environment. It's a challenge because in lab environment, you are seeing simulators. In real life, you have to do some interconnections, but that is fine. Whichever way it is, at the end of the course, you should be able to build an ISP network right from the scratch. And once you're able to build an internet service providers network, why can't you troubleshoot? If I say troubleshoot, I mean, if there's a problem, you should be able to fix it. So we're going to have a deep understanding of the MPLS network. And these are some of the things that we will cover. LDP, MPLS layer 3 configurations, VPN version 4. Then we'll see how to pair our PE to CE using the following routing protocols. Don't let me waste my time going through all these things, but at the end of the day, this will be achieved. Then we also do segment routing. So your CV will be upgraded. You should be able to add all these skills to your CV to enrich your CV. So guys, you have to focus. You have to focus on the objectives of this training. That if at the end of the course, if you are not able to understand BGP fully, or you are not able to build an MPLS network from the scratch, then it means you have not achieved your purpose for joining this class. Okay, so in this class, we have a mixture of people with CCNP and some with CCNA who want to join. So I'm going to come down to the lowest level. Okay, so you all have to be tolerant because some people are in CCNP and they feel maybe some explanation, I don't have to do it, but we have to bear with the CCNA guys. And this model is somehow close to CCIE because the MPLS that we are doing, in fact, we are taking everything. We are doing everything MPLS. So it's more or less CCIE MPLS. Okay. So let's take a look at the internet. I have a diagram here, the area view of the Earth. I just captured it this morning. So this is a portion of the Earth. Now, if you look at this, the internet, if you look at the internet from the area view, okay, even though you're not going to see it as I'm coming to draw, but it looks something like this. Let me use a red pen. What am I drawing? Internet service providers. And they are interconnected to each other. So that is how the internet looks like, basically. All these round things you are seeing are representing internet service providers. Doesn't it look something like routers interconnecting to each other? Okay, come back to our local area network. If you have routers interconnecting to each other, and let's say you have a PC here and another PC here, and they want to communicate, packet will travel, touch this router here, and this router will do its lookup and start forwarding the packets either through this path or through this path to the destination. Similarly, the internet service providers network also looks something like that. If you look at the broader picture. Now, how do we distinguish between these ISPs? They are given special numbers, and those numbers are called the autonomous system numbers, AS numbers. And the company that is responsible for this is called ICANN. So ICANN is responsible for assigning the AS numbers. We have the private AS numbers and the public AS numbers. So if you want to be seen on the internet, you have to go for a public AS number, not a private. Public, this one. Private AS numbers ranges from 64,512 to 65,535. So this range is for the private. So when do we use private and when do we use public? As the name implies, so I'm sure we all have some knowledge in private IP address system and public IP. If you want to be seen publicly, you use the public AS number. So I'm sure all these ISPs, internet service providers, let me say, for all you know, this one is MTN. Let's say this is MTN. MTN is an ISP. We are in Ghana, so let's use our service providers. Maybe also Section can give us some internet service provider in US. Kofi, please, can you name us one ISP in US? Kofi, are you there? Okay, let's call it AT&T. I'm not so sure. AT&T. So AT&T is also connected like this. Now, all these service providers are distinguished with their AS numbers as we've established. So assuming this MTN has an AS number of, let's say, 55, this one will have an AS number of 107, and on and on and on and on. So now we have seen the picture of how service providers are interconnected. So based on this diagram, let's pick, let's say 2 or even 3 ISPs. Okay, so we zoom into this diagram. We have another ISP here and one here. So AS number is, let's say, 10 and AS number 20, AS number 30. What is inside this cloud? It's a collection of routers. The routers are interconnected to each other. So that's what we call the network of the internet service provider. So at the end of this program, you should be able to build this network. You should be also able to interconnect one ISP to another ISP. Once you're able to do this, achieve this, connecting from one ISP to the other ISP, the rest, you can do it. Okay. So one, we'll build this ISP using BGP. BGP is not the only option. You can also use MPLS to build this ISP. What's the difference between MPLS and BGP? MPLS can offer a lot of services. Okay, so if you have ISP and in your core network, let's call this one a core network. In your core network, you are using BGP, and the other ISP is also using MPLS. The one using MPLS will score more points than you. Why? Because MPLS can offer a lot of services. It can offer layer 2 services. It can offer layer 3 services. Don't worry about that. We'll learn all these things. And BGP is somehow limited. So that is why most internet service providers have resorted to using BGP in their core. So BGP routers within the same autonomous system.
Hello, Chief.
Hello?
Sorry, my light went off, so I had to switch from router to my cell phone data, and I missed that part. I got up to after the course. One should be able to build, let's say, this AS number 10 cloud, and then interconnect it with the other clouds.
Okay.
But the rest, I missed all of that.
Okay, then you have not missed much. You have not missed much. So
okay,
we are saying that at the end of the program, we should be able to build this core network here. Okay, building this core network, we can use either BGP or MPLS, multi-protocol label switching. And we also said that it's preferred to use MPLS to build your core network, because MPLS will give you a leverage over BGP. If you're an ISP and you are using MPLS in your backbone, your customers are entitled to a lot of services. You understand? So I'm sure that is where you lost.
Okay, thank you.
Welcome. So now, when do you need to configure BGP? When do you need to configure BGP? Most of the time, enterprise service, enterprise network guys, do they need BGP? It depends. It depends. You need BGP if you're an ISP. You understand? If you're an ISP, BGP is a thing for you. What if you're a customer? Let's say you're a customer here, and please, 1 minute. Hold on 1 minute. Hello. 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 You're a customer here, and you are subscribing to a service of an ISP. So let's say you are connected to this ISP. That is my company, and that is MTN, and MTN is providing me with a service. Do I need BGP? Or what point will I need BGP? If I have this simple connection to my internet service provider, I don't need a BGP. I don't need to configure BGP in my network. All I need to configure is a default network. Okay, so on my router here, I just configure a default network and point it to the ISP's interface. Okay, so that my clients here, anytime they want to connect to any website, when the packet gets to the edge router, there is a default route which sends the packet to the ISP. The only point which will require me to need BGP is when I have a public IP to advertise. Okay, so supposing I have a public IP here in this network, I have, let's say, a 196.201.41.0/28. And this public IP, I'm hosting some servers here. I have some servers here on this network that I'm hosting. And I want people to have access to this network. In that case, I'd like to advertise this public network to my internet service provider, and they will in turn send it out to other ISPs so that any user who is connected to any other service provider, if they want to reach this network, they will have access to it. Good. If I have this public IP address in my network, I still don't need BGP. There's no need. Okay, you can talk to your ISP here, and your ISP will just configure a default route pointing to your network. A default route, as in, if you want to reach 196.201.41.0, subnet mask of /28, 240, you drop it on, assuming the interface here is 1.1.1.1. Drop it on 1.1.1.1. So my ISP is responsible for that. They will configure a default route and point it to me. So if I have a public IP, and in most cases, most companies don't have public IPs to publish on the network or to advertise. But in case you have it, you still don't need to configure BGP on your router here. Just leave the burden on your ISP, and the ISP will configure a default route and point it to your network. And that default route, your ISP here will redistribute it inside BGP. We'll do that, don't worry. They'll redistribute, okay? They will, what other word do I use? Don't worry. They will redistribute the public route, this static route here, inside of BGP, and BGP will carry it along to other autonomous systems. So in this case, this enterprise network, I still don't need BGP. The only time that will require me, the enterprise network, to use BGP is when I am multi-homing. If I say multi-homing, this is what I mean. If I say multi-homing, this is what I mean. So I'm not satisfied with, I'm not content with just one internet service provider, because what if this ISP goes down? It means I'm also down. So in that case, I use a different internet service provider. Okay, let's say Vodafone. So I have two ISPs, ISP1 and ISP2. We call this one multi-homing. So when I have this multi-homing, then it will be necessary for me to use BGP if I want to advertise this public network. Okay, so the subtopic, when do we need to configure BGP? One, we need to configure BGP if we are ISPs, internet service providers, or if we are internet enterprise network and we have a public address to advertise, and we are also multi-homing, then we will need BGP. We will need to configure BGP on our network. Okay, any questions so far? Any question?
Yep, Nat, can I ask a question? So if you are an enterprise, when do you say you have a public IP to advertise? And when would you not have a public IP to advertise?
Okay, so if you're an enterprise and let's say you have certain web services, let's say Google or even Yahoo. It's a company, they have their enterprise network, yet they have their servers that people access publicly. You understand? If I open the browser and I enter yahoo.com, I'm actually accessing their server from the internet, and that server has to be advertised publicly on the internet. Okay, so let's assume this is Yahoo, that is their company, and on one of their networks they have this public network, and on this public network they have installed some servers, and this servers, they want the reason why they use public IP is they want people to be able to access it over the internet. In that case, this public IP here should be advertised on the network. So that's to answer your question. An enterprise network, when do you need to use a public IP? You need to use a public IP if you have some servers that you wish to advertise publicly, or you want people to access it from the internet. But if you don't have any of those services, there won't be the need for you to go in for a public IP. It will not be necessary. Network address translation is a technology that can allow your enterprise users to access the internet. So, Kofi, is your question answered?
Yes, sir.
Okay.
I have a question.
All right, sir.
So, like what you're talking about with Yahoo. So let's say Yahoo uses the services of
let's say Vodafone
AT&T.
Let's say Vodafone and MTN. Let's bring it to our level.
Okay. The services of Vodafone, and then Vodafone provides them with, let's say, a /29 IP block to use. So, and then they assign some of the IPs to their servers, which can be reached, publicly.
Yeah.
So what's the difference between that and then Yahoo going to the people who assign the Afrinic for public IPs for their servers? What's the advantage of going? Yeah.
Okay, so normally enterprise companies will not go to Afrinic for public IPs. Normally, it's only internet service providers that go for Afrinic. Afrinic is under ICANN. Okay, they are responsible for Africa. So ISPs in Africa. All right. So Afrinic will not deal with enterprise network per se, because it's hierarchical. Enterprise network, if you want to browse the internet, you can't do that unless you connect to an internet service provider. So if you need a public IP, your ISP will do that for you. Okay. All right, so those who join us newly, at the end of every 40 minutes, our Zoom will go off, then we have to reconnect. Okay, so we have just 1 minute for it to go off. So let's cut it and reconnect. I'm stopping it. Please connect immediately.